All right, so this is another example of an equation that's not a function that we want to take the derivative of. And we are just looking for the first derivative of this. We're going to go through and break this up and find the derivative with respect to x of all of these terms. So for the first one, the derivative with respect to x of x to the third, that's just a simple use of the power rule, and you get 3x squared. For the next piece, you will see that this is the derivative with respect to x, but inside here, this is x times y. That means I have to use a product rule here. So let's go ahead and set this up. My first term will be x. The derivative of x is just 1. The next value is my u, which is my y, but the derivative of y with respect to x is going to give me that dy dx. So inside here, I am left with the derivative of u, so that is y, and then I add that to the next two, which is x times dy dx. And that's the product rule using implicit differentiation. And then I add that to, again, the derivative with respect to x of y squared. I need the dy dx. Then I go through and take the derivative of y squared using the power rule, which becomes times 2y to the first. And the derivative of the constant 7 is just 0. Let's go ahead and simplify all of this out now. And I'm left with 3x minus y minus x dy dx plus 2y dy dx is equal to 0. Now, what we have to do, and our goal here is still the same, I still now need to solve for and find the first derivative, dy dx. I do that by putting all of the dy dx's on the same side of the equation. So for this, I'm going to move both the 3x and the y over to the other side. Doing that leaves me with negative x dy dx plus 2y dy dx is equal to negative 3x plus y. Now, because I have two dy dx's here, think of them as the GCF and factor that out. So dy dx comes out, and I'm left with negative x plus 2y is equal to negative 3x plus y. And now to get dy dx by itself, I'm dividing both sides by negative x plus 2y. So my final answer here is the first derivative, dy dx, is equal to negative 3x plus y all over negative x plus 2y. You might find that you can factor out a negative and change that to 3x minus y over negative x minus 2y and turn both of those into a positive. That's also an alternate solution. All right, so this is another case where we have to use implicit differentiation, and you will also have the product rule here. So I'm going to use a little bit of different notation as I'm doing this. So you see that we have dx of x squared and y. Then the same thing is we have to also take dx of y squared x is equal to negative 2. And there's no reason for the different order in here. It's just different. You can change it. It doesn't matter. Now, I'm going to use the product rule here. When I'm using the product rule, what does the product rule say? First, what it says, I take the derivative of the first term times y, and I add it to the derivative of the second term multiplied times the first. So what I've done here, all of this is the product rule for this first portion. So now I'm doing the same thing again. I take the derivative of the first term multiplied times the second, and I add that to the derivative of the second term multiplied times the first. And all of this is equal to 0, and it's equal to 0 because the derivative of a constant is just always going to equal 0. So let's go ahead and do the differentiation. So with the derivative with respect to x of x squared, that just leaves us with 2x times the y. That's all of this. I add that to, now my second term here, this is the derivative of with respect to x of y, so that leaves me with dy dx times x squared. You could also do this with a u and v notation, meaning that u is equal to x squared, u prime is 2x, v is equal to y, v prime is equal to, I need the dy dx here because it's the variable y with respect to x, times, and that's 1. And you'll see that you'll get the same answer either way. It is 2x times y for the first term, and then it is x squared times dy dx for the second portion. Continuing with the derivative, I want to take the derivative of x with respect to y, which gives me dy dx. Now I take the derivative of y squared, which is 2y. Then I go ahead and bring down the x. And now I take the derivative of x, which in this case is 1, times y squared is equal to 0. And again, you can set this up with the product rule. And we're referencing the product rule here of the second term in terms of u and v, if you wish, meaning that u in this case will be y squared. The derivative of y squared is 2y dy dx in this case because we have the y variable. And then the v portion would just be x. So v is equal to x. The derivative of v is just equal to 1. And again, you'll see the same thing. It's 2y dy dx for this first piece that I have here. And then the second part is the y squared times 1, which I have here. You can use either sets of notation. Now I want to clean up this a little bit. Now I'm left with 2xy plus dy dx of x squared plus dy dx of 2xy plus y squared is equal to 0. At this point, I would recommend you go back and just double check all of your signs, double check you did all of the differentiation correctly. All right, we're still underneath the same goal of solving for dy dx, which means I need to get and isolate these two terms all by itself. I do that by taking the 2xy and subtracting it and moving it over. Same thing with the y squared. When I do that, I am now left dy dx of x squared plus dy dx of 2xy is equal to -2xy minus y squared. 2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y squared. 2xy minus y squared is equal to -2xy minus y s On the left-hand side, I factor out dy dx, and now I'm left with x squared minus 2xy is equal to negative 2xy minus y squared. Divide both sides, and we are left with dy dx equaling, I can factor a negative out of the numerator if you want, negative 2x. That becomes a plus y squared all over the denominator of x squared plus 2xy.